In this video, we will explore applications of quadratic equations. So in this first problem, it says the product of two numbers is 64. One number is 12 more than the other. Find the two numbers. So these are word problems. So remember how we set up word problems. We always started with defining variables. So in this case, we have two unknowns, but we can, so one number is 12 more than the other. So what I'll do is I'll say let the smaller number be x, and then the larger number is 12 more than that, so x plus 12, right? 12 more. So then it says the product of two equations, so two numbers. So product means to multiply. X plus 12, and this is equal to 64. And now we have to solve this equation. So this is a quadratic. And how do we solve a quadratic? You want to first make it look like a quadratic, and then you want to set it equal to 0. And then you want to factor. So what numbers multiply to be 64 while adding negative 64 while adding to be 12? So let's see, negative 64, 8 and 8 is certainly a pair, but that's 0. So that's a negative. So one of them has got to carry a negative. And so let's see, 64 divided by 2 is 32. So I'm going to put the negative on the smaller number because they've got to add to be a positive 12. And then, so that's clearly not going to add up to be positive 12. So 32 divided by 4 is 8. So negative 4. Oh, wait, what did I do? 64 divided by 4 is 16. And I think I found it, 64, negative 4 and 16. So because these two add to be positive 12. So we can say x minus 4, x plus 16 is equal to 0. And then use our 0 factor property. And 2, x plus 16 equal to 0. And add 4, x is equal to 4, minus 16, x is equal to minus 16. Now, be careful. So in these kinds of word problems, we always connect back to the numbers. So the smaller number is supposed to be x. Also, it says positive number. So that means that although 16 came out of the process, it's not necessarily to consider. So we can say that the first number is 4, and then the second number is 12 more than that, so that would be 16. Now, if that positive was not there, then the first number would be 4 and the second number would be 16, would be certainly one answer, but then you would have another answer using the 16 as well. Alright, so next problem here. You're designing a large sign to advertise a new book at a convention. The length of the sign is to be 3 feet more than the width. Signs of the convention cannot exceed a maximum area of 54 square feet. Okay, so let's draw a picture of this. Here's my sign. The length of the sign is to be 3 feet more than the width. Okay, so if I'm going to say W is my width, and so then the length would be W plus 3. Okay, then signs cannot exceed a maximum area of 54 feet. So now this is a rectangular sign, and since it's a rectangular sign, area is length times width. So in this case, it's W plus 3 times W, and this must work out to be 54. So again, we have a quadratic equation that we need to solve. So this is W squared plus 3W equals to 54. Let's pull the 54 over. And now we are after numbers that multiplied with negative 54 while adding to be positive 3. So negative 54, clearly 1 and 54. Let's set up the signs. This will have to be positive, that will have to be negative. Okay, that doesn't work. 2 and 27, still too far apart. 3 and 18, getting closer. Still no go. How about 4? 54 divided by 4 doesn't work. 54 divided by 5 doesn't work. How about 6? 6 and 9. There it is, right? There is my pair of numbers that multiplies to be negative 54 but adds to be positive 3. So we will say W plus 9, W minus 6 is equal to 0. So 1 W plus 9 is equal to 0. 2 W minus 6 is equal to 0. So we can say that W is equal to minus 9 or W is equal to 6. Now let's connect this back to the width. Well, when you're talking widths are lengths of some kind. You don't get negative lengths. So the only answer that makes sense in the context of this problem is W equals 6. So you would say the width is 6 feet. Remember to give units, and the length is 9 feet. This last problem here says one leg of a right triangle is 14 feet longer than the other leg. The hypotenuse is 26 feet. Determine the length of the triangle. Okay, so this refers to the Pythagorean theorem. So let's talk about the Pythagorean theorem a moment. Pythagorean theorem. And the Pythagorean theorem says applies to right triangles, meaning a triangle with a right angle. And what it says is if you have a side of length A and another side of length B, and the hypotenuse and use is C, and that's important, it's only the hypotenuse that can be C, then A squared plus B squared is equal to C squared. So this is an important little formula to keep in mind. So for us, in our little problem, it says one leg of the triangle is 14 feet longer than the other. So we have a right triangle. They told us it's a right triangle. And when we talk about legs of a triangle, they're usually talking about the sides that are not the hypotenuse, because they'll explicitly say hypotenuse if they're talking about the hypotenuse. So in this problem, for instance, the hypotenuse is 26. They tell us that. So it says one leg is 14 feet longer than the other. So I'm going to call this one X. That's the length of that. And so then this would be X plus 14 feet longer. And now I can use the Pythagorean theorem. And the Pythagorean theorem says X plus 14 squared plus X squared, A squared plus B squared, is equal to 26 squared. Now carefully unpack this. So we have X plus 14 times X plus 14 plus X squared equals to 26 squared. So 26 times 26, 676. And so let's go ahead and distribute here. I'm going to get X squared plus 14X plus another 14X plus 14 times 14, 196 I believe. 14 times 14, yep, 196. And then don't forget that last X squared equals 676. So let's combine like terms. 2x squared plus 28x plus 196 is equal to 676. And well, that's a quadratic, but I'm going to move this problem down a little bit so we have more room. Oh, didn't mean to move it over there. Down. Okay, that's a quadratic, and so we have to set it equal to 0. So 2x squared plus 28x plus 196 minus 676 equals to 0. So let's do that little math there. 196 minus 676, 480. Okay, so now we're getting ready to factor this. Now don't forget the first step of factoring, and that is to factor a GCF out. So in this case, we can factor a 2 out. There is a 2 here, and 28 is 2 times 14, so there's a 2 there, and this is 2 times 240, so there's a 2 there. So we can factor a 2 out, and that'll make our life so much easier. So if I take a 2 out, that leaves me with x squared plus 14x minus 240. And now I'm looking for numbers that multiply to be 240, negative 240, that add to be 14. So clearly 1 and negative 240, but that's a long ways from where I want to be. So I'm going to jump to, say, 10. 10 and, wait, this has to be negative, that has to be positive. So 10 and 24, right? So that's negative and that's positive. So is that what I want, right? I think so, right? I want numbers that multiply to be 240, those two do, and add to be positive 14. So this inner part factors as x minus 10, x plus 24, and don't forget the 2 equal to 0. So now I can use my zero factor property, and I only need to really worry about the x minus 10 equals to 0 and the x plus 24 equals to 0. Now you may ask why not the 2? Well, the 2 can't equal 0, so I'm not going to worry about it. So x is equal to 10 over here, and x is equal to negative 24 over there. Now, what are these answers make sense in the context of the problem? Again, the negative answer doesn't make sense. Now, that's not always the case. Be careful. Don't just assume the negative answer doesn't make sense always. But just in this problem, the negative answer doesn't make sense. So what are the lengths of this triangle? 1 is 10. So the triangle lengths, triangle sides are 10, 24, and 26. Alright, so the next problem I'll do in another video, in the next video, because this one has gone on for long enough.